Here's another application of a radical equation, this time involving speed. So we can see in this question that we're given a function that will take the length of a skid mark in feet, x, to give us s of x, which is the speed of the car before the brakes were applied. So s of x is speed, and x is the length of the skid mark. So there's some relationship between the two. And we can see in the graph, there is some sort of relationship. Kind of looks like a parabola, but turned on its side, which makes sense. You'll explore that more in MA 102. So we're finding the speed of the car before the brakes were applied if the skid marks are 361 feet long. So looking at that, that would be somewhere in here. So I should get a value somewhere between 60 and 80, but we'll find the exact value. And then how long would we expect the skid marks to be if the car had been traveling at 50 miles per hour? That would be somewhere in here. So I'm guessing 175-ish. Not very exact. We're going to do the math to figure it out. So what we're going to do is we're going to use this function. They've already told us that x cannot be below 0, so it has to be greater than or equal, which makes sense in a couple of ways. We know we can't take the square root of a negative value, and that wouldn't make sense in this case anyway, because the x represents the length of skid marks and we can't have a negative length of skid marks. So let's take a look. For part A, we're finding the speed if the skid marks are 361 feet long. S of 361. So I've replaced x with 361 because x represents the length of skid marks, and they told me the length of the skid mark. And so remember on the left side, this is just a way for us to denote s of x. We're just saying we're replacing x with 361. We're not actually going to do anything on this side. So this side stays s of 361 so that we remember that 361 is what we plugged in. When I took the square root of 361, I got 19, and I took that times 3.8 to get 72.2. And again, that would have been in miles per hour. So we're assuming 72.2 miles per hour. Then let's take a look at B. For part B, I'm finding how long the skid marks would be. So I'm finding x if the car was traveling at 50 miles per hour. So at 50 miles per hour, that's this side. So I have a lot of students who want to say 50x, but that is not correct. Remember, s of x is kind of like y. We're saying that represents speed. So I should say 50 equals, and then 3.8 radical x. Now I'm just solving this equation, so divide by 3.8 on each side. And that gives me radical x on the right. On the left, I get a very ugly decimal. But the good news is I'm leaving that very ugly decimal, which is 13.157, blah, blah, blah. I'm not rounding that. So don't do an intermediary round, so don't round in the middle. Take that entire giant ugly number in your calculator and square that number while it's still in your calculator. Now I can round to the nearest foot. So I got 173.130, etc. equals x, because the square root, and then square, those cancel. I'm rounding to the nearest foot, so about 173 feet is x. Here's one for you to try on your own. So try this question, then press play to check your work. So an object is dropped from a height of 50 feet. The time t of x in seconds it takes to reach height x is given by this function. Find the time to reach that height of 20, or what is the height after 1 second. So two different questions. So for part A, the time to reach a height of 20 feet from the ground. And we know that that's going to be x. So we're finding time, which is t of x, for 20 feet. So I'm going to say t of x, or t of 20, I did it again, t of 20 equals 1/4, and then 50 minus 20. So t of 20 would be 1/4, and then 50 minus 20 is 30. Just like I did on the last question, I'm going to take the square root of 30 and it's going to be ugly. I'm going to leave that ugly number in my calculator to divide it by 4, and that's going to be my answer. So t of 20, The square root of 30 is 5.477, etc. I'm going to divide that by 4, which is the same as multiplying by a fourth. And I end up with 1.3693, etc. So what is the time to reach the ground? It is about 1.4 seconds. Sorry, a time to reach 20 feet from the ground. So it's dropped from a height of 50 feet. It takes 1.45 seconds, or sorry, 1.4, I can't even read my own handwriting, 1.4 seconds to reach 20 feet from the ground. For part B, what is the height after 1 second? So that would be t of x. 1 equals 1/4 times the square root of 50 minus x. So we replaced the entire left side with 1 because that represented the 1 second. T of x is time. To simplify this, I would multiply each side by 4, because if I multiplied this by 4, I end up with just my radical, which is what I wanted. On the left side, 4 times 1 is obviously 4. I'm now going to square each side because that's the index. 4 squared is 16. This side squared is 50 minus x. If I subtract 50 from each side, I get negative 34 equals negative x, which of course means 34 equals x by dividing each side by 1. So what is the height after 1 second? The height would be 34 feet. So it started at 50 feet. After 1 second, it's at 34 feet.